spoke about remedials in terms of mass timber, but hopefully we can get to a point where we don't need to instigate remedial action. So I'd like to welcome Paul Newman, Technical Director of the Structural Timber Association, who is going to speak about how to prevent moisture issues in mass timber construction. Welcome, Paul.
Good afternoon, everyone. I just wandered out of shot of the camera, haven't I, if we go over there. So, good afternoon, everyone. Thanks, John, for the introduction. I think I'm the good news today. Now, those of you that have known me for a long time, and there are some of you, will know that I would never normally be described as good news. Those of you that saw the press release when I joined the Structural Timber Association would have seen the words, "I am thrilled to join." My children, well, not children, saw that and said, "Do they even know you?" So, moving onwards. Structural Timber Association, very briefly, we are the trade association for the Structural Timber Association, or the structural timber sector. So our membership are drawn from the supply chain and primarily the manufacturers and designers and constructors of timber systems. And we've got a big share of the market in membership, as you would expect. And we represent the three main typologies of timber frame, SIPs and CLT. We provide technical support to the association, some of which is through me, some of which is subcontracted. We've got a mandatory quality assurance procedure in place for members, which is reaching up in its ferocity from January, which is a good thing. We have trained installers for a scheme there, we're working on design stuff at the minute. And I suppose our mainstay is engagement. We spend a lot of time trying to talk to government, don't always want to listen, don't always want to hear, but we try to spend a lot of time doing that and then link with the rest of the stakeholders in the sector. So I'm going to be talking about what's on the top two lines here, so trying to give you some pointers on good practice and things like that. I'll point you at five publications that the association has written and prepared that will help steer you through this sort of thing, if you are not already aware of it. And now I'm going to get into the meat of the talk. So, stand up if you've lived in the UK in a building and you've never had an issue with water. And I've asked it that way because no one's ever going to stand up. We've all had some sort of problem with a leak in our building, and today is about trying to help you not have those problems, about help us not have those problems. Some of this might be a bit controversial. I hope it's not, it shouldn't be. Some of it might be things that you're not doing at the minute that maybe I think you should. Okay, first one, implement a durability or a design durability risk assessment. Start it at the very beginning of the project. So for some of you, you're not going to see this because you're on the contracting side until later on. Some of you that are on the client and design side, this is what should be in place at the very initiation of the project. What are we designing? What are the risks that we're foreseeing? What are the consequences? What can we do about those? A simple little example. We've seen parapet construction so far. We've seen how water can accumulate behind parapet constructions. Don't do it. What about if we just didn't design a parapet on the building? Have something else instead. If you must have a parapet because of the planning, for design and planning reasons, then how can we stop moisture becoming a problem in that area? So the moisture content, the moisture risk assessment should live with the job. Some of it will be moisture measurement on site, and I'll come back to that on the next slide. So, on the basis that we're all learning, me especially, and we're all limited, some of us more than others, what about holes to visualise leaks? If you're going to have a leak in a building, and we will, let's put a hole in the right place so that when water does come in, we can visualise it inside the building, we see a damaged surface finish, and then we know, hang on, quickly, we know we've got a problem, we can go and fix it. Alternative constructions. So maybe don't use CLT for some of the areas that are most high risk. Use an alternative product in that area. I'll come back to that as well. I like this one. Use a sensitive material as a surface finish. Something that's going to give you a tell. If I've got wet, I've displayed that. Maybe I've gone soft and spongy, so that you don't have to wait for whatever was on the roof of the building to tell you what's going on. Maybe, and I know some of you, this plays right into your hand, some of you, Mr. Sharples, ongoing permanent monitoring in the building. Something that lives with the building for many, many years, if not the rest of its life. And what I would say is, don't be tempted to have to take shortcuts. They will bite you. We know that, we've seen that. They will bite you in the bum, so don't be tempted to take them. Think logically in what you're doing and act sensibly. And that applies during the design phase, during the construction phase, as you're monitoring moisture. And I think if you're not monitoring moisture, you need your pumps feeling. And then if you find an issue during the construction process, before you close up the building, address it. Keep CLT warm, generally. I know you'll all be going, yeah, Paul, but how many times have you not done that? And how many times has it caused you problems? And consider detailing to avoid water traps. Phil showed you a picture earlier with a parapet roof, with the roof going down to form a little valley. Perfect water trap. Water gets in there, tracks up the building. Consider the build process to reduce the amount of water remaining in CLT post-construction. Now, I know he's not brought this here for my benefit, because it's heavy to carry all the way from offices in South London, but Nick from CLT, they've got this product, from KLH, have got this product. And other manufacturers do exist and will have very similar things with a temporary protection membrane on it. Why not specify that on your jobs and make life simpler, reduce the amount of moisture that can get in, and also give yourselves a chance to get the building dry afterwards. I heard the words moisture management plan, I think someone called it earlier. Yeah, great idea. Who's doing it? So where does it sit? We've got some people in here from Opera who work on the client side of things. Should they be doing it? Should they be organising it? Is it something for main contractor? Is it something for subcontractor? Is it something for someone on the client side to be doing? But when it comes to measuring moisture content, who's doing it? How are they doing it? Where are they doing it? What happens to the records? And the critical part in all of this is competency. So there's another, I'm trying to go around the subsets of people in the room. There's another group of people in the room who have spent quite a lot of time looking at CLT buildings with issues. You don't really want to employ them to do ongoing monitoring for you on a weekly basis because it's too expensive. So you need someone who's going to be on site on a regular basis to do it, but they need to be, so that they're affordable, they need to have the right skills, knowledge, experience and behaviour to do the job properly, and they could absolutely be trained by the other people in this room to do that for you. If you check these things and find you haven't got a problem, then it builds confidence for you, for the rest of the team involved in the job. Typical CLT external walls. Rigid insulation. Is that really a good idea? If you are going to go rigid insulation, then I've got two membranes on this. One straight on the face of the CLT. These are breathable membranes in this case. One on the outside of the insulation. And on this version, with fibre, I don't necessarily need one there. In my head, that membrane's not that expensive. Get it on there to protect the structure during the construction process. I'm a bit of a fan of words in red because they stand out and I remember to say the things that I wanted to say. So theoretically, if you've got masonry cladding, and I know that a lot of the buildings won't, but if you have masonry cladding, then it only needs to be vented. Ventilate it. Add more ventilation to it, then you've got more opportunity for drying if it's needed, and don't take the risk. Yes, you'll have to fiddle around with your cavity barriers a bit, but it's a much better idea in my opinion. You're going to get more opinion, you're going to get a lot of opinion from now, or some opinion. In the STA publications, we don't show a sole plate. Why not? In my head, it provides an opportunity to set out the building, to level the building, and this is made from treated timber. I've already ensured that I'm 150 above the ground minimum, and I'm not doing it if it's less. Don't design it if it's less. This is not a good idea. I think Phil said you might get away with it, but you also might not get away with it. We've heard about pockets from Martin. No, stop doing those. And we at least want it like that. And then there was a nice illustration in one of the Swedish wood publications of a nice little metal plinth lifting a big column up. All of these things are a good idea. You might get away with it, you might not. You don't want to find out too late on in the process. Level thresholds. Okay. So this is an example of perhaps how you can do it to avoid a problem. But in my head, there's still a residual risk here. I'd be inclined just to lift the whole lot up and have a concrete plinth. It's a warm wall construction. I'm insulated externally anyway. I can take that insulation down past my threshold, lift the whole thing up, don't have a problem. External walls. You'll keep seeing my yellow lines here. Some of them are from the publication, some I've added in, because I think from what we know now, we want a bit more end sealing going on. Having the end sealing in position is a good idea. It can be done in a factory. Sounds nice, sounds controllable, sounds as though it can be quality assured. Or the alternative is you get someone to do it on site. If you're going to do it on site, you absolutely want to be doing it in my simple little head as the stuff arrives. Offload, coat, offload, coat, offload, coat. So that you know you've got protection to at least that area where you've got the exposed end grain, which we've heard all about is the absolute critical bit. I think I'm going to live with 33 litres of water and a metre squared of surface area of panel for quite a few years after today. That's a lot. Okay. Start doing stuff like this, start following a good practice, and you won't have that sort of issue. Key one on here, I think, don't progress. It's wet, stop, deal with the consequence and dry the thing out. If you're covering up working material, you're going to get the problems that we've heard about earlier. How else can we do this? Localised areas. The areas that are higher risk, maybe because they're flatter, and this is a floor we're talking about now, or because perhaps it's a bathroom in a school. So can we swap out solid timber for I-joists, perhaps in localised high-risk areas? Or is this one of the places where we can include a sensitive material? Something that might be, if it gets a bit wet, it's going to go spongy straight away. So we've got to tell so we know what's happening with the building. Window junctions. Holes in buildings, fill them with windows. Is enough care taken over that junction, over its design, over how it's detailed, the products used, and then who's installing the windows, taking responsibility for that. I'm probably straying a bit from moisture content here, but how are the windows fixed? You know, silly little straps. Are the straps adequate? Have they been designed? Can it be shown to be adequate? Are we fixing to timber battens? Are they fixed properly to support big, heavy windows? And I suppose it is linked to moisture, because if you get movement in those locations, you're going to get water penetration. Have the window designed so that it's going to throw moisture outside of the building, or at the very least down a cavity, but preferably outside of the building. The challenge here, I would say, is an architectural one firstly, and then a construction one, because window details seem to be, cladding and window details seem to be, to me, an endless source of variation. You almost don't see them the same. There's very, very little standardisation in place for that sort of thing. So detail and construct this element, I should have put that up a little while ago, to throw water outside of the building. Flat roofs. Yeah, you can do it. Do you need to design a flat roof into the building? Does it need to be CLT? Could it be something else? Could we, and I know I've just rotated the thing in a bit of a clumsy way, but graphically challenged, I'm limited. Put the CLT on a slope, at the end of the slope at the bottom, put some holes in. I've got enough strength, a few holes big enough to let some water leak through. Isn't going to be a problem. I can even use those holes during the construction process to help me shed moisture out of the building. Put a drain, temporary drain into them, some flat pipe or something to get that moisture out of the building during the construction process. Because it is in the UK, because it will rain, it's not always going to be lovely and cold and crisp like today is. Or maybe I could just switch it for that. And that doesn't just apply to balconies, it maybe doesn't just apply to bathrooms, but what about flat roofs? What about balconies? Is that another place where you might not want to use CLT? Might design something else, and it potentially isn't a timber area in that, or timber material in that area. Pitched roofs. I realised this after nicking it out of the book. A massive great big blue cold bridge there, unless you imply that that insulation is taken down. So take that insulation down, and get as you build the roof, get this membrane on as you work, as soon as you go, or use one of the clever temporary protection membranes that are now available in the marketplace. That's me, just about done, I think. What have we done there? There we go. Back to the beginning. Do this sort of thing. Don't take risks, and think logically about the process. Now, I did just want to finish. I think I've got a little bit of time, because time's already blown. I'm looking to you to nod join in. I've given up now. Charlie mentioned the timber and construction roadmap earlier, and I think there's probably several people in the room who it has passed by somehow, who haven't heard about it, so I thought I'd stick in two slides on it. One, so the timber and construction roadmap is an initiative between government and industry. It was under the Sunak government. It looks now as though it's going to get buy-in from the new government. Cross fingers, following the meeting the other week. And it's got a few things in there to safely, that's not just with reference to CLT, not just moisture, but some of the other challenges as well. Safely increase the amount of timber we use, to increase the amount of homegrown timber, so perhaps not so relevant for today, but it's there anyway, to help us meet our net zero target, which is why Part Z is critically important. We're not going to get that much further on operational energy, and then to help grow the economy through decarbonisation, through all the good work that we're doing. And it does that through 7 priority themes. Each theme has a list of actions, if you will, underneath the titles, So on the safety thing, I think that's where we're mapping out where all the CLT buildings are. On the carbon things, it's improving the quality of EPDs that are available, increasing the number, improving the quality. Probably the biggest challenge in all of this is skills. Where are all these people coming from who need to construct buildings from in the future? Years and years ago, I had a thing, construction industry finds it hard to recruit because it's dull, dirty and dangerous. And working with CLT and with other timber systems, I think we have the opportunity to change that. That's me done. Hope that was useful, hope it was interesting. Thank you very much.